Hello everyone, I am Dr.S.ARUNKUMAR, Assistant Professor, Department of Mechanical Engineering, SNS College of Technology, Coimbatore. So in the continuation of video series of refrigeration and air conditioning concept, in this video I am going to discuss about the principles and applications of refrigeration and the air conditioning systems. So this is the presentation overview. I am going to discuss refrigeration and air conditioning, fundamentals of R and AC system and vapor compression cycles and alternate systems, air conditioning principles and some of the real world applications like food preservation, healthcare environment and data centers and also the transportation. Finally, I am going to discuss the design thinking stage, how the refrigeration and air conditioning system adopted the design thinking and innovation concept for the best working environment. Finally, the future outlook. In the design thinking concept, I am going to discuss the empathize stage and also the ideate stage. So this diagram represents the working cycles of air conditioning systems. This has the four main key components: condenser, expansion valve, evaporator and the compressors. So this lecture explores the fundamental principle and diverse applications of refrigeration and the air conditioning systems. In this lecture series, how these essential systems manipulate the how to create the comfortable environments as well as preserve the goods. So understanding these systems is crucial for designing the energy efficient building, developing the sustainable cooling solutions and also ensuring the optimal performance in various industrial processes. Some of the key areas are thermodynamic cycles and system components and real world applications and also the design challenges in the air conditioning and the refrigeration systems. So in the previous lecture series, we already discussed main components of vapor compressor refrigeration cycles are condenser, expansion valve, evaporator and the compressors. So these are the main components where the vapor compression cycle is the most common method of refrigeration. It involves the continuous loop of refrigerant undergoing the phase change to transfer the heat from the cold space to the warmer space. So these are the types of refrigeration system. Here we are going to discuss some three types of refrigeration systems. The first one is absorption system and thermoelectric cooling system and cryogenic system. Coming to the absorption system, it utilizes the heat energy, example the waste heat, to drive the refrigeration process, making them suitable for the situation with the available low grade heat sources. In the second type of refrigeration system, thermoelectric cooling, it based on the Peltier effect. These solid state devices offer compact and vibration free cooling. It provides the vibration free cooling, often used in the small scale or specialized applications. In cryogenic systems is designed for extremely the low temperature conditions. These systems are crucial in the scientific research, medical application and also some advanced electronics applications. So in the air conditioning principles, it extends the refrigeration to control not only the temperature, but also it controls the humidity, ventilation as well as the air purity for the human comfort. So cooling and dehumidification process, the air passes over a cold coil and lowering its temperature and removing the moisture from the environment. In the air filtration process, it removes the particulates and allergens and pollutants and foreign materials, improving the indoor air quality. In ventilation process, the fresh outside air is introduced inside the house or inside the room or inside the environment, diluting the indoor contaminants and providing the oxygens. So some of the real world applications are food preservation, extending the shelf life of the perishable goods in the homes, supermarket as well as cold storage, and data centers, preventing the overheating of critical servers and maintaining the optimal temperature. It should be maintained in the optimal conditions, then only the data centers work properly. In healthcare conditions, in maintaining the sterile environment as well as the preserving the medicines and cooling sensitive medical equipments. In transportation applications, it comfort cooling in vehicles and the refrigerated transport for the some of the milk products, some of the refrigerant frozen goods. Coming to the design thinking approach, empathize stage, by observing and engaging and immersing ourselves in the user experience. From the user feedback, we can frame the problem statement. We uncover the unarticulated needs and the pain points. For instance, in a hot climate like our country, India, understanding why current air conditioning system are inadequate or too expensive to run. Because in the conventional air conditioning system, which provides improper cooling, ununiform cooling, as well as it consumes the more power consumption. So the Ideate stage, it focuses on generating a wide range of creative solutions to the identified problems without initial judgment. This phase encourages divergent thinking, brainstorm of new refrigerant usage and passive cooling designs and hybrid cooling solution and smart control system. These small control systems is developed by using the artificial intelligence driven system for optimal energy usage. So this is one real-time case study, sustainable building cooling. It considers the design of a modern office building aiming for net zero energy consumption in a hot climate. The challenges is to maintain the comfort while minimizing the environmental impact. Integrated solutions are geothermal cooling, chilled beams and smart glassing and passive ventilation. In the method of passive ventilation, maximizing the natural airflow and night purging. So this integrated approach significantly reduces the energy consumption compared to the conventionally heating, ventilation and air conditioning systems. So some of the future outlooks are: innovation is the key, continuous research into the new refrigerant, finding of new refrigerant and energy efficient designs, and also sustainability focus and integrated systems. So the integrated systems gives the proper cooling and it consumes the less energy compared to the conventional air conditioning systems. So these are some of the references I have gone through for this lecture series. Thank you for your watching. Thank you.